All right, guys, here we go. So our job is to find all the x and y values that will make this inequality true. But like I said, this is an inequality. We've been dealing with equations for a very long time now in chapter 3. When you solve an equation, you get very concise answers like x equals 3, y equals 5. You start working with inequalities, now you get answers like x is less than 3. Guys, there are infinitely many numbers in this world that are less than 3. You get answers like y is greater than 5. There's infinitely many numbers that are greater than 5. So an inequality is going to have many more answers to it than an equation. So if I want to find all the x and y values that make this inequality true, there are so many answers to that I have to show the answers on a graph. All right, so what we're going to do first, you're trying basically to find all numbers you could plug in for x and y that make this add up to something that is less than or equal to 5. Guys, there are tons of numbers out there that you could plug in. I could do 1 and 3. They add up to 4. That's a number less than or equal to 5. I could do negative 10 and 8. They add up to negative 2. That's a number less than or equal to 5. So there's tons of answers. So the way we're going to get all of the answers is we're going to graph it. So since this has an x and a y in it, when we go to graph that, we always solve it for who? Y. We get y by itself, so we can think about y equals mx plus b form, and we're going to graph it as a line. So we're going to create this boundary line between x and y values that are answers and x and y values that are not answers. So to solve it for y is super easy. That's minus x from both sides, and we get y is less than or equal to negative x plus 5. So now we have the inequality compared to y. So let's graph it as a line. Think of this as y equals mx plus b. Who's your b? Who's your y-intercept? 5. Go up 5. And then who's your m? Who's your slope? Negative 1 over 1. So rise over run. We're going to rise a negative 1, and we're going to run a positive 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. And then go the other way. Instead of going down 1, right 1, do the exact opposite and go up 1 and left 1. And take the slope in the other direction. All right, now, here's a detail you had to remember. We're looking at this from y now. We only want the y values that are less than or equal to the points on that line. So guys, you're allowed to equal the points on that line. So do you want to use a solid line or a dashed line? Solid would show that they're included and you can equal them. So we use a nice solid line. All right, so let me show you what's happening. Every single ordered pair that lands on this line, let me label a few. 0, 5, 1, 4. 2, 3, 3, 2, 4, 1. Guys, every single ordered pair right now, x and y, what do all of these numbers add up to? 5. Right. They're the ones that are going to make this say x plus y is equal to 5. Right? 4 and 1. 4 plus 1 is equal to 5. 3 and 2. 3 plus 2 is equal to 5. Any point on the line are the points that make it equal to 5. So there are solutions. They're allowed to be included, and that's why we use a solid line. All right, well, what about all the x and y values that make it add up to a number that is less than 5? Now we have to show where they are. So that's where the shading is going to come in. We're going to shade where all of the x and y values are that make this add up to a number that is less than 5. So guys, we're comparing it to y right now. We want y to be less than or equal to the points on this line. You have y values living on the y-axis, getting bigger and bigger and bigger above your line on this side. You have y values getting smaller and smaller and smaller below your line on this side. If you want y to be less than your line, should you shade where y is above or below? Below. So any ordered pair that lands below this line or on it is a solution to this system. Or I should say this inequality. So think about it. 0, 0 is where we shaded. Is 0 plus 0 less than or equal to 5? Yeah, because that's where the solutions are. All right, so where does this relate to our systems? Well, guys, the last section we have to cover in Chapter 3 is Section 3.2, and it's on systems of inequalities. So we just spent the past, 3 weeks solving systems of equations. And you had to find specific x and y values that make all of the equations true. Now we're going to find a bunch of x and y values that make both inequalities true. So they're going to add a second inequality, and they're going to make it a system. And you're going to graph a second inequality right on top of this one. And wherever their shading overlaps is the solution to the actual system. And that's what we're going to do today. All right, so let me give you your notes. Now, because your homework is on Delta Math, I wanted you guys to see it. So if you have a Chromebook or a phone, could you take it out? I made a Delta Math assignment as our notes, so you guys could follow along on Delta Math on your notes. Because I didn't give you any graphs here. You're going to graph it on Delta Math. So use your phone or your Chromebook. You need something. Like I said, you're going to be doing it on Delta Math. Yeah, I did send a text like, oh, no, Kayla, I'm so sorry.
You're stomping on the phone.
All right, yeah. All right, here we go. So if you're going to solve a system of linear inequalities, your goal is to find the x and y values that make both inequalities true. To do this, you're going to solve each inequality for y, so you can graph your line. Think y equals mx plus b. Even though we're working with inequalities, we still want that slope-intercept form. I did put or solve it for x if there is no y, because guys, we're back to graphing lines technically, and there are horizontal and vertical lines, and they only have an x or a y in their inequalities. So if it's only an x, that's a vertical line, and you're going to have to solve that inequality for x because there's no y there. It's the only variable you could solve for. All right, you're going to graph each inequality and shade accordingly. Watch out for your solid or dashed lines. That was a kind of annoying, like, technical detail you had to watch out for. And then the answer to the system is going to be the overlapping shaded region. I did put a reminder, a warning on here. When you start solving inequalities for y, what happens if you divide by a negative number? You want to flip that symbol. Please don't forget to do that. All right, so let's look at example 1. Here is a system of 2 linear inequalities. Our job is to find the x and y values that will make both of these inequalities true. I don't want just x and y's that make him true. I don't want x and y's that just make this one true. I want x and y values that will make both of these a true statement. Are both of them already solved for y? Then we're good to go. Go right to Delta Math. Let's graph this. Let's start getting that answer. So on Delta Math, oh, hold on. Give me 2 seconds. Okay. I needed to clear them. All right, here's the first problem. So I lined them up. Same 2 inequalities. Let's graph them. So I'm going to graph the top one. What's his y-intercept? 5. So go to 5. Click it. Got a dot. The minute you click it, a line automatically appears. All you have to do is use your slope one time to move to another point. So guys, the slope is -1 over 1. So let's go down 1 and right 1 and click it. Do I want a solid or dashed line if I only want y to be less than the line, not on the line?
Dash.
Dash. So now you just got to hit that change line button until it changes to a dashed line. All right, now we got to put the shading. Guys, look at your y-axis. We're compared to y, so it's all about y versus your line. You got y values getting bigger and bigger and bigger than your line on this side. You got y values getting smaller and smaller and smaller than your line on this side. If you want y to be less, who should you shade on? Where y is above it or below it? So shade here. So now you just hit the change shade button until the shading appears on this side. I mean, there's only 2 sides, so it should only take you 1 or 2 clicks. Change. Perfect. Went right there. So guys, right now, any x and y value, any ordered pair that lands in this blue area makes that inequality true. But I don't want just x and y values that make him true. I needed to make this one true too. So let's graph this one right on top of it. So he has a y-intercept at -1. And he's got a slope of, so let's go up 2 and right 1. rise over run. Solid or dashed line for this one? Solid. Now y can be less than or equal to the points on the line. And now we gotta do our shading. So guys, picture the yellow line only. You got y values getting bigger and bigger and bigger on this side of the line. You got y values getting smaller and smaller below your line on this side. If I want y to be less, should y be above or below? So this side, make sure the shading is on this side of that yellow line. And please look for clues. Guys, he had a negative slope, he went left. He had a positive slope, he went right. Make sure your line slants the right way for the correct kind of slope. All right, change shade. Oh, perfect. We're good. All right, so guys, anything that falls in the blue makes the first true. Anything that falls in the green makes the second one true. But this blue-greeny region right here, I think it just looks darker on yours. This section right here, that's where they overlapped. So these are the x and y values that will make both of them true because that's their common shaded area. So now what Delta Math is going to make you do to make sure you really see the solution set is if you scroll down underneath the graph, they ask you to pick a solution point. They ask you to pick a point that landed anywhere in here. Guys, there are literally infinitely many points you could pick and be correct. So everybody in this room could probably pick a different ordered pair and be correct. There's not just one right answer. So guys, any point that you see that doesn't land on a line, don't pick one on a line because that's specific to that inequality. Pick any ordered pair that point blank lands in this double shaded region. Guys, look at all these options. Pick any one of those. What's up? X goes first. So I always play the game like, oh, who are my favorite numbers? I'm a big fan of 4, and I'll go -4. So I'm going to pick that point right there. 4, -4 is an X and a Y value that I know would make both of these statements true. So you plug it in right underneath it. And again, you can pick a different one. Go ahead, Jake.
Wait, I thought if it's less than it goes to the left.
Okay, here's the problem with Y's. There's no, Y's are either above or below your line. To think in a left and right situation, that's thinking about X. If you're comparing things to Y, Y is either going to be above or below. It's not left or right. It's above or below. All right? What did I say? -4, no, 4, -4. Hit your submit answer and get your green check. All right, let's go to example 2. On your notes, example 2, is the first inequality ready for you to graph it? Yeah. Is the second one? Yeah. All right, so everybody solve that for Y, and then we'll go to Delta Math. I just want to make sure you guys practice solving for Y because Delta Math didn't have that, and you really should keep those skills fresh. So you solve this for Y there, I'll solve it here. Let's see if we get the same inequality. Watch your signs. Don't do anything silly. And then always divide and reduce when you can. What are you going to divide by to get Y by itself? So what do you have to do to your symbol because it's a negative number? Make sure you flip that symbol or you definitely won't be shading in the right direction. What's up? It should once you've put an answer in. Oh, wait. Yeah, because I couldn't make it solve it. I had to, yeah. Don't do that, Derry.
No, I solved it.
Yeah. All right, so then we got that. So now we have the first inequality and the second inequality ready to go. We're going to find the X and Y values that make them both true. So now go to Delta Math, and those should be the 2 inequalities that example 2 has. And let's graph them. All right, example 2. All right, I'm going to graph the first one. I'm just going to talk my way through it. Hopefully you guys are doing it. I'm going to go to a y-intercept at -7. He has a slope of -3 over +1. So rise over run. Let's drop down 3. And let's run to the right 1. Solid or dashed?
-7, no.
Oh, you're right, Gary. Hold on. How do I? Oh, good call. See, it's a good thing you guys are here. All right, -7. All right, we're going to go, what did I say? Up now. Now, if you find that going down 3 and right 1 brings you off the graph, then use the slope in the other direction. Instead of going down 3, right 1, go up 3 and left 1. Solid or dashed?
Solid.
Solid, less than or equal to means we can include the points on the line. And now let's do our shading. So guys, here it is. Here's your line. You got Y values getting bigger and bigger and bigger above your line on this side. And you got Y values getting smaller and smaller and smaller and smaller below on this side of your line. If you want Y to be less, we shade below. So make sure you're on this side of the line. So hit that change shade until you're there. There we go. All right, let's graph the other one. Positive 8 is its Y-intercept. And then 3/4. So you could go up 3 and right 4, but that breaks me off the graph. So I'm going to do the opposite, and I'm going to go down 3 and left 4. Good? And then our shade. We got Y above it on this side, and we got Y below it on that side. If I want Y to be greater, should we be above or below? Above. So on this side here. And there it is. So guys, anything in the blue makes the first inequality true. Anything in the green makes the second inequality true. But anything right here in that overlapping dark area, that's a solution to both inequalities. So pick your favorite. Guys, look at all the options. Look at all these options. Now, obviously, there's a ton more that we can't see. But because we can't exactly see what will fall above or below the line, stick to one that you can see. So pick your favorite numbers. Anybody have a preference?
-8.
I was going for -8. -8? 5. Right there. Take it. -8, 5. Plug it in. That is a solution to both systems. Now, I am finding that some students are like, hey, Marty, I got it wrong. They're counting their slope wrong. That's the biggest mistake, is students just counting the slope wrong, and it's making the point that we pick not correct on yours, because your slope isn't counted correctly. All right, let's go to example 3. Go ahead, Brendan.
No.
Are you okay?
Yeah.
Are you sure?
Were they both straight lines?
They were both solid in that one,
Oh.
because they both had a less than or equal to. If they have that equal to symbol, that means you can include the points on the line. So the equal to always gets you that solid line. All right, guys, example 3. Is the first inequality ready for you to graph it? No. So everybody solved that one for Y, and the second one looks good to go. I'm a big fan of putting 1 in front of that X when I go to solve, so I can see who I'll be dividing when I go to get Y by itself. To get Y by itself, guys, I'm about to divide by 3. Should I flip my symbol?
No.
No, right? Only if you divide by a negative. Okay, hopefully you feel pretty comfortable with this. So now we have our first inequality ready to go and our second inequality. Let's head over to Delta Math. Let's throw them on a graph and see where this solution set is. Is everybody okay?
No.
No, Brennan, what's wrong?
I'm doing nothing.
We'll start over. You have -7, and you went 1, 1, 2, 3. Left one looks good. So -7. Let's go up 3 and left 1. You want it to be solid, and you want to shade your Y as left or below, so on that side. Good. And now we have this line, right? You went up 8, down 3, and left 4. Now where should you be shading? Where is Y greater? Where is Y above that line? So there. Oh wait, I got one line shading. Hold on. Oh, we got rid of it. Had to change. Is there a change line button over there?
Why?
Okay, now
Should I go first?
there it is. Now any point over there, pick one. All right, let me catch up. What do you got?
Is this all we're gonna do today?
Yeah. Well, yeah, the last example is like nutty, but
I don't know, my brain, see if I can.
I don't want you to see the last example. All right, we got this one. I'm going to catch up to you guys. I'm going to graph +8, -1/3. I always give the negative to the top number, so I'm going to make that a -1 and go down 1, and then I'm going to run to the right 3. That's a negative sloping line, so it should slant left. Always look for the clues that you're graphing things right. Then we can shade. I want a solid line because it's greater than or equal to. I have y's up here above. I have y's down here below. They want y to be greater, so shade where it's a above. So just hit that change shade, perfect. All right, graph the next one. I'm gonna go to -4, and then my slope is 5/3. Up 5, right 3. Solid or dashed, anybody? Dashed, because now we can only be less than the line. And then our shading. We got y values up here above it, and we got y values down here below it. I want y to be less, so shade where y is below. So it should be this little tiny section up here. Right? We got blue, making the first one true. We got green, making the second one true. And then that little slice of pie over here, that's the solution to this system. So pick any one of these points, and you should be good to go. I'm going 8, 7. All right, last one. I want you guys to do the last one. Well, it's the technically last one. Go to example 4 and do example 4 if I haven't caught up to you yet. Maybe you've already done it. Solve that for y. On the notes, please make sure you're solving them for y. Then you can go to Delta Math and graph it. What do you got?
I got the last one wrong.
Look at check mine. Do we have the same inequalities?
Yeah, I did it exactly.
Which when you say the last one, the one we're doing right now, or example 3? Okay, so you went. You had to go up 8. You're at 6. You get 8. And then you want down 1, right 3. Yeah. All right. Let me catch up and see if we look the same. All right, enough of you, knuckleheads. All right, we got -1, my y-intercept, go down 1. Slope is -1, down 1, right 1. Solid or dash line, stay with me. Solid. Are we shading above or below if y has to be less than? No. Perfect. All right, y is greater than or equal to 5 halves x minus 8. I got to go down 8. I have to go up 5 and right 2. Solid or dashed? Solid, greater than or equal to. Kayla, thank God you're here. And I want y to be greater. So should I shade above or below this line? Above. There it is. Perfect. So guys, this huge section of double shaded region, any ordered pair in that is a solution to this system, right? Green make the second one true, blue make the first one, but that right here, I'm going -2, 0. I'm going right there. Nice and close. Easy number. Okay, all right. So we're done with Delta Math. Now I want to do the last one on the homework. This one is where it should feel like Algebra 2. You can find any single one of those systems in an Algebra 1 book. I want to show you an Algebra 2 version of these systems. So look at example 5. We can't do it on Delta Math Delta Math did not have it in their question bank, so could you do me a favor? Just draw yourself your own graph real quick. Nice, easy, neat, and big. Make it big. This is gonna hurt your eyes, so make it big so hopefully it'll stay a little bit neater and organized. This one's gonna get wild. I'm gonna color code mine because it's gonna get crazy.
You put the numbers too?
What's that? Yeah, I just give yourself like up to 6 tick marks on your X and Y.
10 of them.
Oh, 10, you got plenty. I'm going big. All right, here we go. Let's do this. All right, so when you work with systems, they can pick as many inequalities in the system as they want. We tend to work with a system of 2 equations, 2 variables. We tend to work with a linear system of inequalities, 2 inequalities, 2 variables. Guys, you did see though, there are 3 equations, 3 variables out there, so they can get bigger. So with the inequalities, they can start putting more and more inequalities that you would have to graph and see where the graphing and the shading overlapped. So when they give you this statement, guys, look at it. When we had inequalities written as those sandwiches, if you will, those were compound and statements. So compound meant there's 2 inequalities written there. This is more than just 2 inequalities that we have to abide by. So if we break this up, guys, this inequality says -3 is less than or equal to x, which is less than or equal to 5. But if you read it from x's point of view, there's 2 things going on. X has to be greater than or equal to -3. That's one condition. And X has to be less than or equal to 5. So guys, that's 2 inequalities that we have to grab and see where they overlap, because we want to make sure we meet both of those conditions and make both statements true. If you read the second inequality, it says 2 is less than or equal to y, which is less than or equal to 6. If you read that from y's point of view, there's 2 things happening. Y has to be greater than or equal to 2, and y has to be less than or equal to 6. Guys, there are 4 inequalities in this system. So we have to graph all 4 of them and see where they all overlap and who's going to be the solution set to make all 4 of these inequalities true at once. So now here's the good part. If we go to graph this inequality, how many variables do you see in his statement? So guys, it's a horizontal or vertical line. Just when we were graphing straight lines, if it only had 1 variable, it was a horizontal or a vertical. It didn't slant, it didn't have a slope to worry about. All right, so guys, first I want you to graph the equation x equals -3. Think of it as the line. X equals -3. Where's x -3? Right, left, up, down? Left 3. Put it up. That is the line where x is constantly -3. Every dot has an x coordinate of -3. Draw me another point that has an x coordinate of -3. He does. Draw me another dot that has an x coordinate of -3. He does. He does. What kind of line is being formed when x is always -3? So we got a vertical line. Do I want it to be solid or dashed? Solid. I can be greater than or equal to -3. So give yourself a solid vertical line. All right, now we have to do the shading. They want x's that are greater than -3. So where are x's going to be greater than -3? To his right or to his left? So as lightly as you possibly can, shade to the right, because we're going to have to graph a lot on top of this, and we have to see where the shading overlaps. So just very lightly, give yourself some shading to the right. Anything to the right of this line makes our first inequality true. Got it. Now let's graph our second one. I'm going to do it in red. First, I want you to graph the line x equals 5. So where is x equal to 5? Right, left, up, down? Right 5. Draw me another dot that has an x equal to 5. He does. He does. He does. Again, what kind of line is being formed when x is always 5? Vertical. Solid or dashed? Solid. All right, now I want very lightly, let's add his shading. X has to be less than 5. So should I shade to the right of 5 or to the left of 5? Okay, very lightly. And look for where the shading is already starting to overlap. Okay, guys, this red out here only makes him true. This black out here only makes this inequality true. But do you see the overlap? If I'm in the middle of these two lines, they make both of these statements true. These are numbers that are bigger than -3 and less than 5. So right now, if that was our only two inequalities, this would be our solution set, right smack in the middle of these two vertical lines. But we have two more, so now let's add them. I'm gonna go blue next. Y is greater than or equal to 2. First, I want you to graph the line y equals 2. Where is y equal to 2? Up, down, right, left? Up 2. So put a dot, we're up 2. Draw another dot that has a y coordinate of 2. We're trying to be y is always 2. He does. He does. He does. What kind of line is being formed when y is always 2? Horizontal. Solid or dashed? Solid. So now they want y to be greater than 2. So should I shade above the blue line or below the blue line to be greater than 2? Above. So guys, out here, only the red and blue overlap. In here, the red, blue, and black overlap. And then out here, only the black and blue overlap. So our solution right now is in between the verticals and above the blue. So it's kind of making a box. In between and above the blue. All of this stuff in here. All right, we got one more. I'm going to do it in green. Y is less than or equal to 6. First graph the line y equals 6. So where's y equal to 6? Up 6. 2, 3, 4. Draw another dot where y is 6. Here, here, here. What kind of line is formed? Again. Horizontal, solid or dashed? Solid. And now they want y to be less than 6. So should I shade above the green or below? So out here, it doesn't all overlap yet, but there it is. There it is. This is where the eyes start to hurt. So as long as you are below the green, above the blue, to the left of red, and to the right of black, this rectangle in the middle is the solution to this system. Let me get black. So this rectangle in here is the solution to this 4 inequality system. Do you see that? Those are the x and y values that will make all 4 of those statements true at the same time. If you pick a number in here, let's say this is what? This is, where is it? What is it? 2, 4. Right there. 2. Is 2 bigger than -3 and less than 5? Yeah. Is 4 bigger than 2 and less than 6? Yes. Those are the numbers that will make both of these inequalities true. The homework doesn't make you do anything as in-depth as that, but I do need you to know that they're out there. They can keep adding inequalities to the system and just keep making more and more shaded areas for you to have to abide by, okay? All right. As always, you have a homework on Delta Math that is due tomorrow night. The Delta Math should post any minute now. I had it posted, I think, at 1:30. All right?